Assalamualaikum and very good day. My name is Masita Hassan. And also introduce my team members, namely TS Dr. Hanida Abdul Aziz, Dr. Wan Nolinda Roshana binti Muhammad Nawi, and Nur Izanuddin. I want to introduce our digital risk assessment tool developed specifically for civil engineering laboratories at FIMIEX campus. This innovation transforms the way hazards are identified, risks are assessed, and controls are implemented, that making safety management more consistent, structured, and efficient. This project developed a digital risk assessment tool for civil engineering lab to help OSH committee or PIC lab to identify hazard and determine a risk level within FIMIEX campus. In most civil engineering labs, high-rate documentation is still done manually. This creates inconsistencies, misplaced records, and increased human error, especially when PIC or technician frequently change. This can inspire us to develop a centralized, more structured and standardized e-hierarchy system tailored for FIMIEX laboratory operations. Next, for state-of-the-art or methods, our tool introduces a digital e-assessment approach that uses historical risk data to generate more accurate and consistent risk scores. It guides users step by step from hazard identification to selecting the most effective risk control based on the hierarchy of controls. This method reduces subjectivity and ensures standardized decision making in the lab. This is the interface of the tool. It is designed to be structured, organized, and compliant with ISO 45001-2018 requirements. The tool centralizes all risk information so that supervisors, technicians, and OSH committees can access the same standardized format. With guided prompt, hazard identification becomes much faster and more systematic.
Here is the interface of risk assessment tool for civil engineering laboratory, or we call it as e-hierarchy tool. This tool is developed entirely using Microsoft Excel, supported by macros and VBA programming. The interface you are seeing now is the Excel-based user interface that consists of several sheets. The first sheet is the main page of the tool. On this page, you will see 11 buttons that lead to the complete hierarchy document for each laboratory. Which are here? This is a hierarchy carpentry lab, hierarchy brick lab, hierarchy highway lab, hierarchy plumbing lab, hierarchy environmental lab, hierarchy concrete lab, hierarchy geotechnic lab, hierarchy hydraulic lab, hierarchy survey lab, hierarchy structure lab, and the last is hierarchy photogrammetry and cartography lab. Users may select any laboratory they wish to view. Okay. On the right hand side of the interface, there is a new hierarchy form button, orange color, that opens a blank form for entering new data such as new activities or newly identified hazard. Below this button, there is not explain the function of column B to N in the risk assessment tool. We call it as checklist for e-hierarchy. Column B is for activity kerja, column C for routine, column D for hazard, column E menyebabkan atau kesan or impact, column F kawalan semasa, column G kebarangkalian, column H for keterukan, column I for risiko, column G for peluang, column K for perundangan, column L for kawalan atau tindakan dicadangkan, column M pegawai yang bertanggungjawab, and column N tarikh selesai. Okay, now let us click the new HIREC form button to view the interface. Here you can see the blank HIREC form. Each field must be filled in according to the username displayed. For the R or NR field, there is drop-down menu like this, as well as the likelihood and severity values. Also use the same drop down with selectable values from 1 to 5 like this. 1 to 5 skala or scale. At the bottom of this form, there are 4 buttons, which are save, modify, delete, and reset. Save is store the data, modify for allows editing or incorrect entries, delete for remove all the data, and reset for clear the form fields. Save like this, modify, delete, and reset. Okay, this icon takes you back to the main page, while this icon opens the database sheet where all submitted data is stored. On the right side of the interface, we will find notes on the risk level with corresponding colors, severity scales, likelihood scale, and the types of hazard commonly found in civil engineering laboratories. Next, we'll move to the second sheet, which is database. This sheet compiles all the data entered through the HIREC form. Each activity and hazard is assigned a serial number on the left, which is important when making the correction. From this database, all organized data can be copied and pasted into the respective HIREC template for each laboratory. This is how we generate the HIREC document for every lab. It is simple. Simply return to the main page and select the desired laboratory. For example, here is the HIREC for the carpentry. This is the correct template for the audit ISO. The color of the risk based on the number of risk value, which are green for low risk, yellow for medium, and red for high. If you wish to add new activities or hazards, simply enter the information into the HIREC form here and identify the serial number in the database. To improve a risk level and reduce them to a low or green category, you need to complete the control measure or recommended action. Then copy and paste the update item into the corresponding HIREC template following the serial number. Repeat this step for other activities and hazard until all risk minimized based on appropriate countermeasure or action. Okay, that concludes my introduction to this tool. Although there are still some limitations that have been identified, the tool can be improved and upgraded from time to time.
Okay, the next for benefits and usefulness for this tool. One of the main strengths is ability to reduce human error because risk levels are calculated consistently. Unlike generic tools, this system is tailored specifically to TVET's academic and administrative workflows. It blends traditional hierarchy principles with digital automation and making the process faster, clearer, and more reliable. The novelty of this invention lies in its specialization. This is the first digital hierarchy tool built specifically for civil engineering laboratories under TVET. It uses real risk data for quantification and embeds ISO 45001 2018 principles directly into the workflow, ensuring consistency and credibility. This tool is highly marketable because every polytechnic and community college with civil engineering labs can adopt it. With 30 potential institutions, the estimated commercial value is Rm 60,000. Beyond financial returns, the tool strengthens institutional safety culture, ensures compliance, and simplifies audits. The primary users include PIC labs, technicians, and OSH committees. Okay, next for environmental impact or sustainable development goal. The project supports SDG 8 and SDG 9 by promoting safe, sustainable, and innovative practices. Transitioning from manual to digital assessment reduces paper usage and aligns with environmental sustainability goals. Next for cost analysis. The development cost is relatively low because it uses existing resources. Institutions will benefit from long-term savings through reduced paperwork, fewer repetitive trainings, and more efficient audit. Market surveys show that typical risk assessment tool exceeds 5,000 ringgit, but our unit cost is only 2,000 ringgit, making it highly competitive. The tool is currently at TRL 5 to 6, which means it has been tested in an actual operational environment and is ready for broader implementation. Lastly, about achievement and publications of this tool. The innovation has been recognized as a strong entry for internal competition and is currently in the pilot testing phase. It has also produced 2 publications, a Scopus paper, and 1 international conference proceeding. In conclusion, this risk assessment tool is an impactful, scalable, and practical solution that elevates safety management in civil engineering lab across the TVET campus. Thank you.